Hi everyone, welcome back to News Chem Corner. Yes, 2025 AP Chem exam is over. I hope you did really well. Some of my students already text me like the exam was super easy, so I'm really glad to hear that. I think all of your other exam is also over. AP exams are over. So this may be the right time to discuss the AP, the latest questions, right? Let's get started the AP FRQ 2025 discussion. Here we go. So the first question is about mass spectroscopy, right? Okay, mass spectrum, they were given an incomplete mass spectrum and you need to complete that one. Okay, what are the data they were given? Magnesium spectrum is given, which is 24, 25, 26 are there. Only 24, 79 percentage is given and the others are equal percentage. Okay, so the total is 100 percentage. So definitely if this one is 79 plus and the others are equal, so 2x is equal to 100, right? So what may be the percentage of other? Yes, 10.5. So you can draw a graph or line with showing 10.5, right? So 25 is 10.5. Similarly, 26 is also 10.5, like that. You can draw like this. Okay, that's all. And the second question is describe the difference in atomic structure that account the difference in mass between 25 and 26. Oh, super easy, right? Okay, what is the difference in their 25? Why the magnesium 26 is higher in mass? You know, it's isotope. Isotopes are different in their neutron number, right? So magnesium 25 contain 25 minus magnesium atomic number is 12. So 25 minus 12, that many neutrons are there. But magnesium 26 contain, yes, 26 contain 26 minus 12, right? So definitely one neutron is higher than the magnesium 25. So that makes the weight difference. Okay, right. Then the third question, they were taking some MgNO3 twice and NaOH solution and some molarity is given. Okay, and the question is about interaction with water. Okay, and the I felt what I felt in this exam. It's super easy. Why? Because they were already given all answers. Then what you just want to do, just explain why is it so. And the clue is also they were given, isn't it? See, in this question they were already given magnesium having higher attraction with the water. Okay, this is a solution, magnesium nitrate solution. So definitely you can expect Mg2 plus and water interaction, right? So water, you know, it's a polar. So oxygen and hydrogen is look like these, and definitely oxygen is partial negative. So oxygen have to attach with the Mg2 plus solution. So this will be the interaction, one of the interaction in this magnesium nitrate solution. Similarly, NaOH is also there in another beaker. So in that beaker, Na plus having an attraction with the oxygen, and they were telling already, they were told Mg2 plus have stronger attraction. Why? They were already given the clue also. Okay, so first you need to explain why use of the relative charge of ion, because you know these are opposite charges, right? 2 plus and partial negative charge. So opposite charges are attractive. So opposite charges attractive means they follow Coulomb's law of attraction. What's the Coulomb's law? According to Coulomb's law, if higher the charge, higher will be the attraction, isn't it? So here Mg2 plus is higher than the Na plus. See, the charge, relative charge is higher for Mg2 plus. So definitely attraction is higher in the point of view of charge. And another important factor affecting like Coulomb's law is distance between the charge. Okay, so if distance is higher, then attraction will be lower. So here which one is higher in what distance? Definitely the atoms, if it having higher radius, which means this charge is separate, far apart, right? So which one is lower in radius? You know that in sodium is here, it's a third period, and magnesium is also in the third period, and left to right size decreases. So magnesium is lower size than the Na. So lower size means they are more attracted or more nearby to the negative charge of oxygen, which means there is more attraction. Okay, so if the distance between the charges is very less, then attraction will be also higher. So definitely magnesium have higher attraction. So you can explain based on these 2 points. Okay, charge over radius. Usually we are telling charge over radius ratio, right? So in that way we can explain why magnesium have more attraction with the water. Okay. Then the third question is the same. Second part question is calculate the pH of the solution 2. So what is the solution? A beaker 2 is NaOH solution. NaOH, you know, it's a strong base. It's a strong base. So definitely if 2.80 times 10 to the power of negative 4 molarity of NaOH means what is the OH minus concentration? That is also the same. NaOH concentration is equal to the OH minus concentration because it is a 1:1 ratio also. So 2.80 times 10 to the power of negative 4 is the OH minus. So when you are taking negative logarithm, you can calculate the pOH first and then you can calculate the pH. Okay, right. Then pH will be pOH. When you take the negative logarithm of this value, you will get 10 to the power of negative 4. You will get a 3.5. Then pH will be what? 14 minus 3.55. Okay. So in that way you can get 10 to the power 10.45. So the significant figure also matters. You know how many significant figure is there in the concentration? See, there are 3 significant figures are there. So in your thing also contain 3 significant figure. Okay. Make sure pH means after the decimal point the significant figure count. So 10.45 like that also you can represent. Okay. Then the next question. Okay. So they were mixed this together like the beaker 1 and beaker 2 mixed together. Then you have to calculate the Mg2 plus solution after mixing. Okay, but before reaction. Okay, so the mixtures are just mixed together, so we are expecting some reaction, but before reaction what is the molarity of Mg2 plus? So is it same like the beaker one? No, it's not the same, right? Because we are adding like extra volume is there, so your volume is changed, so definitely magnesium nitrate concentration is not same this one. Okay, so how do you calculate the magnesium concentration? Same number of moles divided by, so what is the number of moles? Number of moles divided by, or here even not need, just you can think about M1 V1 is equal to M2 V2, right? In that way that may be easy. In that way you can simply calculate. We are just diluting, right? We are just diluting this one, or we can use separately M1 V1 is equal to like number of moles and divided by volume, same thing. Okay, I'm directly using that M1 V1 is equal to M2 V2. So yes, V1 is equal to M2 V2. Okay, so before mixing, what is the molarity? 1.85 times 10 to the power of minus 3. 1.8385 times 10 to the power of minus 3 times the volume is 35 and the other one is okay. So M2 we don't know, and the volume now it is a total volume. Okay, so we have to add these together. So 85 ml is there. Okay, no need of converting to the liter, just apply M1 V1 is equal to M2 V2. I think 85. Yes. So what is the M2? Yes, I got some 7.62 times 10 to the power of negative 4 molarity. Okay, so again, how many significant figure? 3 significant figure. So in your answer also should contain 3 significant figure. Okay, that's all. Next one, the dissolution of magnesium hydroxide is given, and yes, they were given the KSP value also. First, expression of KSP. Expression of KSP, you know, KSP is just equilibrium constant. Equilibrium constant, how do you represent? Equilibrium constant means product concentration. So here the products are Mg2 plus concentration raised to their power and like stoichiometric coefficient, and the other thing is OH minus raised to their stoichiometric coefficient divided by the reactant concentration raised to their power. But you don't want to consider the reactant because it is solid. Okay, we are only consider gas or aqueous states in while calculating the KSP. Okay, so that's the KSP expression. This is the thing. Then the second question, E part second question, after two solutions combined, okay, before any reaction taken place, OH minus is given. concentration is given, and you can write the Mg2 plus concentration from the top. Okay, after mixing concentration you can take, just substitute. What is Q? Q means nothing, the same KSP expression, right? But what is the difference between QSP and KSP? Yes, Q means at any time you can take this thing. Okay, at any time you can take this expression. That is what we called Q. KSP means it definitely it should be in equilibrium. So if you don't know whether the system is under equilibrium or not, we can't say it is KSP, right? We can just tell QSP, and if it Q is equal to K, then you can say it is at equilibrium, like that. Okay, so here Mg2 plus, let's see is it equilibrium or not. Okay, so here magnesium 2 plus we already found there 7.62 times 10 to the power of minus 4, and OH minus they were given 1.65 times 10 to the power of minus 4, but raised to power 2 is there, and the value you can get 2.07 times, again 3 significant figure, minus 11. Okay, so this is the Q value. Okay, then the next part, using this Q, predict whether precipitation is forming or not. Okay. So precipitation, Q is equal to K, then you can say it is equilibrium or otherwise saturated. If Q is greater than K, that is what you mean by precipitation. Equilibrium is shifted to left. Okay. In the reactant side. So solid phase. Isn't it? So that is the thing. Q, if it is Q is higher, then the product is higher. So they will do some to decrease the product concentration, they will do the backward reaction. Backward reaction means solidification, like precipitation reaction. Okay, MgOH twice forming a reaction. See the things? This is our equation. Okay. This is our equation. So what happened here? Q, see the comparison. KSP is 5.61 times 10 to the power of minus 12. Here it is minus 11. So definitely Q is greater than K here. Right? So this is a yes, precipitation is formed. Okay, precipitation will occur and the equilibrium is shifted to left. Okay, that's why precipitation is occurring. Okay, then the last part of this question. In separate experiment, student add HNO3 to decrease the pH of a saturated solution containing undissolved MgOH twice. Okay, so what we have, this MgOH twice solution is there. Okay, their equilibrium we already found. What it is, Mg2 plus and 2OH minus, like that it is there, and you are added some extra HNO3. So how this HNO3 will affect this undissolved solid amount? That is the question. Okay, so HNO3, it's a strong acid, so they will dissociate like H plus plus and NO3 minus. So definitely this H plus will react with this OH minus. So what happened? H plus OH minus reaction will take place. So OH minus in effect decrease. So when OH minus is decreased, system will try to increase it. Isn't it? According to Le Chatelier's principle, system will try to increase it. So system will do in forward reaction. Equilibrium is shifted to right. Correct? Equilibrium is shifted to right. So that causes a more dissolution of MgOH twice. So what happened to the amount of undissolved MgOH? That will decrease. Okay, so more forward reaction will take place. Forward reaction, so amount of MgOH twice will decrease. Okay, this will decrease. That is the thing. I hope you understood. We can come back with the question number 2. Until then, bye.